Okay, I want to go over the solutions to the practice test for the surface area and volume. And you might notice that at the top here we have the abbreviations. P is the perimeter of the base of the solid, B is the area of the base of the solid, and so on. So if you forget what those things mean, take a look up here because they'll be on the real test too. Okay, so in problem number 1, you're told that you have a right rectangular prism. And you're also told what its base is. Its base is A, B, C, D, that rectangle down there. For rectangular prisms, we need to tell you what the base is because you could use other opposite sides for bases. For other types of prisms, if you see anything that is not a rectangle, it will have to be the base. Okay, so problem number 1 is vocabulary. It's just asking to find a base edge. Well, a base edge is what it sounds like. It's an edge of the base, like segment AD is an edge of the base. Now there's another base up here, and at the top there's always a pair of bases on prisms, and they're always parallel to each other. So you could answer one of the sides of this top up here, which like segment HE would be 1. So I've listed here for base edges that you could have any one of segment AB, segment BC, segment CD, or segment AD. And I should have also put in there that you could have had any of these. You could have had segment HD, segment HE rather. You could have also had segment EF, segment FG, which is up right here, or segment GH. So actually any of those would have been right. I just responded with the base that you were given. A lateral edge of the prism. Basically, if an edge, which is where two faces meet, if an edge like segment HD is not a base edge, it's a lateral edge. So, four lateral edges are shown. There's segment HD, segment EA, segment FD, or segment GC. And those are the heights of the prism. In right prisms, they are always perpendicular to the base, and we will be dealing with right prisms on this test. So your answers were any of these: C, G, H, D, A, E, or BF. Okay, on number 3, I'm giving you some values that CD is 4. I've marked it on the diagram there. AD is 5, and AE would be 6. And we want the perimeter of the base. We want the height of the prism, first of all. Well, the height is this 6. The lateral edge length is your height. We want the perimeter of the base, the area of the base, lateral area, and volume. Well, I've got them worked up here. Your base, remember, is a rectangle that's 4 by 5. So its opposite sides will be congruent. They'll also be 5, 4. So you have 2 sides of 5, 2 sides of 4 for a perimeter of 18. The area of the base is just an area of a rectangle. It's 4 times 5 is 20. The formula for lateral area is perimeter times height. So we know both of them. The perimeter we just calculated at 18, and the height was in the picture at 6. So 18 times 6 is 108. And the volume is the area of the base times the height. Not a very good B there. The area of the base times the height, which was the 20 that we figured out up here, times 6. Okay, on problem number 4, this is sort of a work it backwards algebra problem. You're given total surface area and base area, and you want lateral area. Well, the formula for a total is its lateral plus 2 bases. So just fill in 136 where you see T. L is what we're trying to find, and it equals 2 times the area of the base, which was given to us as 18 over here. So we just solve this, and we get the lateral being 100. Uh, Number 5 is a similar type of problem. Here we know the volume. We know DH. Now if we go back and look at what DH is the height of the prism. So when it says DH is 5, it's really telling you the height of the prism is 5. It wants the length of BC. Well, I'm going to draw just a picture of my base down here real quick. It's A, B, C, D, and in this problem, A, B is 2. There's A, B, C, D. And we want to find BC. Okay, so over here, the volume is the length times the width. So let's just call this 2 for length, and instead of calling that x, we'll call it w. So 2 times w there is the area of my base. So 80 is 2w, filling in for the area of the base, times height for the 5 for the height of the prism. So w is 5. On the second page, number 6, you're given a right triangular prism. And it has right triangle ABC as its base. It has right triangle ABC as its base. Angle ABC is a right angle. I put a right angle in there. AB is 3. BC is 4. In class, we marked out what it said there. It was DC equals something. And CF is 10. Okay, now we have to figure out for our base the third side that's missing. And we'll use the Pythagorean theorem because our base was a right triangle. So 3 squared plus 4 squared is x squared. And you solve this to get x being 5, square root of 25. Okay, that means that we can figure out the perimeter of the base being 3 plus 4 plus 5, which is 12. What this number is right here, that's the height of the prism. It's the distance between the triangular bases. So your answer so far is the height was 10, the perimeter is 3 plus 4 plus 5, which is 12. For the lateral area, all we take is perimeter times height. So since it's perimeter times height again, this is still a prism, it's just 12 times 10. It's our two previous answers added together. And the volume is the area of the base times the height. Now, to figure the area of the base, remember the base is a right triangle. And in a right triangle, the two legs, those are the sides making the right angle, can always be used for the base and the height. So up here I've calculated that B, the area of the base, using the triangle formula, is 1/2 base times height, and 1/2 3 times 4 is 6. Therefore, the volume, which is the area of the base times the height, is 6 times 10 is 60. And appropriate units, since we began in centimeters here, our lateral area was square centimeters, and our volume was cubic centimeters. On problem number 7, we have a right cylinder, and we know the radius and the height. Well, those are the only two things that are in the formulas for right cylinders. So this is just a plug-in problem. The lateral area is 2 pi RH, so it's 2 pi times 3 times 4, which is 24 pi. And the volume is pi r squared h. So that is pi times 3 squared times 4, or 36 pi. Down here in the solutions, I've given it both with pi in it and then also as a decimal. Either way would be fine. Number 8 is a right cylinder problem, and we know its height. We'd like to know the radius of its base. We also know its lateral area. So in problem number 8, you want to take the formula that's on your formula sheet for the lateral area of a cylinder, and it's 2 pi RH. Plug in what we're given in the problem. The lateral area was 20 pi equals 2 pi r, which is trying to find, times the height of 5. Okay, we can divide both sides now by pi. It will be gone. And over here, 2 times 5 was 10. So 10r is 20. Divided by 10. R is 2 on problem number 8. Problem number 9 is about a sphere. So here was the answer for 8. And the sphere, we're given the radius, and we're going to find total surface area and volume. Well, again, radius is the only variable in the sphere formulas. So on number 9, the total surface area is the formula 4 pi r squared. That's on your formula sheet. So that would be 4 pi times 3 squared, or 36 pi. The volume is 4/3 pi r cubed. So that's 4/3 pi times 3 cubed. These guys, when worked out, are both 36 pi, which as a decimal is 113.1. On number 10, we're going to work backwards a sphere formula. We're given the total surface area at 200 pi, and we want to find the radius. So we set the formula for t, which is 4 pi r squared, equal to 200 pi. Divide by pi, and you get 4r squared is 200. Divide by 4, r squared is 50. R is the square root of 50, which is approximately 7.1. It's also 5 root 2 if you simplify that root 50. On 11, we've got a cone problem. And we're given the height, we're given the radius and the slant height. Now we have to find the height on that guy, and we should know that the radius, the height, and the slant height are on a right triangle, always on cones. So we're going to go 4 squared plus h squared equals 5 squared, and h is going to work out to be 3. The lateral area is given by the formula pi rl, and we already knew r and l, the slant height, at the beginning of the problem. So pi times 4 times 5 is 20 pi, or 62.8, whatever you like. And the total area is lateral, well, it's the pi rl, which we'd already figured out to be 20 pi, plus pi r squared. Comes out to 36 pi again, and that's the familiar 113.1. How many cubic feet are in a cubic yard? Well, since a yard is 3 feet, then if you think about a picture of a cube, which I think we talk about again maybe on the last page, and I've drawn this again, then a cube is x by x by x, and this time it's 3 by 3 by 3 feet. So the area of its base is 3 times its height is 3, or length times width times height. 3 cubed is 27. Okay, a cube has a base edge of 24. All right. Again, there's a shortcut formula for this guy that makes it maybe easier. I'll show you the long way and the short way, and you can decide what you like. But the base is 2 by 2, so the area of the base is 2 times 2 is 4. The perimeter of the base would be 2 times 4 is 8. The height is also 2. Cubes have all their edges the same. So if we use the formula for lateral area, that it's perimeter times height, 8 times 2 is 16, and then if you use the formula that total is lateral plus 2 bases, we already figured out the base being 4 there, we get 24. Now, a much quicker and easier way to do a cube is to realize all of its faces look like that, and every one of its faces has an area of 2 squared. So the total surface area on a cube can always just be 6 times its edge squared, and 6 times 2 squared is a quick way of getting that 24. The volume's the same way. You could compute the volume as the area of the base, 4 times its height, because a cube is a prism. And 4 times 2 is 8. The quicker way, though, is the volume is just 2 cubed. In general, it's x cubed when its sides are x's. Okay, next page we have a regular hexagonal pyramid, and when you think about getting these regular guys here for the bases, think about using 1/2 AP, although this one we could have used 30, 60, 92, but 1/2 AP will work all the time for the area of the base. when you have regular polygons. Okay, we're supposed to name the vertex of the pyramid. That's where all the triangular lateral faces meet at the top. It's the point, so it's G. And name the base. The base is the hexagon. With pyramids, the lateral faces are always triangles. They're always congruent isosceles triangles. So if you see anything that's not a triangle on a pyramid, it has to be the base. So a hexagon is our base. Okay, on problem number 16, we're given that AB is 12 and the height of the pyramid is 20. Well, AB, 12 here, is a base edge. And so what I've done is I've gone through the central angle method, which we always use with regular polygons. The measure of the central angle is always 360 divided by the number of sides 6, which is 60. That always divides up equally, and your base edge of 12 divides up equally as well into 6 and 6. Coming right down the middle of that triangle is the apothem. I'm going to go through the trig method because that's what most of you, I think, use. The tangent of 30 is opposite over adjacent. It's 6 over a. So the a and the tan 30 switch places. A is 6 over tan 30. And we're going to use that over on the area of the base. Now, we had to figure out on this part what was the perimeter of the base. Well, 12 sides that are 6 each. 12 times 6 is 72. So using 1/2 the apothem times the perimeter, we get 371.4. Now here I used the 6√3 that I got in this method, but you would have just plugged in, if you did the tangent method, 6 over tan 30 would replace the 6√3. You get the same answer either way. On number 17, we are given that lateral area is 60, and AB, again a base edge, this time is 6. Okay, and we want to find the slant height. Well, okay, number 17 I've got worked out up here. If AB is 6, then the perimeter would be 6 sides, 6 each is 36. We're given the lateral area at 60, so we plug it in here, and the only variable left, because we have the perimeter to plug in there, is the slant height. We just solve this carefully, and we get 10/3. And that is our answer there for number 17. Number 18 tells us what the area of the hexagon is, and tells us that the height of the prism is 2. Well, the volume is just on a prism is 1/3 the area of the base times the height. Well, we were given the area of the base and the height, so we're just plugging directly into the formula. The numbers were given in the problem to get 80 over 3, which is approximately 26.7. Okay, 19 is a triangular pyramid, and we can also use the 1/2 AP method on it. There are other ways to do that as well. So we know the base edges are 10√3, which means that that's going to get split up equally into 5√3 each. The measure of the central angle, 360 over 3, is 120, which gets split up into 60 and 60. Now it looks like I've used 30, 60, 90 here, but I'll also add in how you can use trig, again, because most of you do that. But if I use the 30, 60, 90 rule that is on your formula sheet, long equals short root 3, then 5√3 is a√3. The apothem turns out to be 5, so this ended up being really easy here. The perimeter would be 3 times that 10√3 for the side length, or 30√3. So the area of the base is 1/2 the apothem times the perimeter. 1/2 of 5 times 30√3 is 75√3, or about 129.9. If you'd used trig there, you would have said that the tangent of 60 is 5√3 over a. So a would have been 5√3 over the tangent of 60. Certainly that's a lot harder to plug in than just plain old 5, but many of us have gone this route. So the only difference is that when we calculated 1/2 AP over here, instead of having 5 there, you would have 5 root 3 over tan 60, but it still would have worked out to the same answer. And to find the height, we're going to use the fact again that in a pyramid of any type, the height, the apothem, and the slant height are always related by the Pythagorean theorem. So I use my 5 that I found out here. 5 squared plus h squared is 13 squared. It works out to be 12. It would have worked out that way as well if instead of 5 right here, you'd had 5 root 3 over tan 60. In fact, what might have been nice is if you happen to have typed into your calculator, in my calculator here, 5 square root 3 divided by tan 60. There's 5. So you could have seen it that way. Alrighty. Here we have a square-based pyramid. They are by far the easiest type because in a square-based pyramid, this segment FG is your apothem, and it's just half the base edge. So all I need to do is put a little 6 there, and we're going to be good to go. So what segment's length is the height? Well, the height goes from the vertex to the middle of the base and forms a right angle in regular pyramids, and all of our pyramids will be regular. So segment EF is your height. Slant height comes down a lateral face. Essentially, it is the height of a lateral face. It hits the midpoint of that side and at a right angle. And EG is your slant height. Next, it wants a lateral face. Well, a lateral face are any of these triangles, ABE, BCE, DCE, ADE. You see them in the picture. Here is a triangle. Here is a triangle. In the back, EDC, and on the left side, EAD. The square is the base. Okay. On number 19, we get that BC equals 12. They tell us that EF, which remember is the height, is 8, and it wants EG, which remember is the slant height. So I've drawn a little triangle here with the apothem, the height, and the slant height. Again, in every right pyramid, regular pyramid, you've got that relationship. In cones, the only thing happens is the A turns into an R for radius. Alrighty, what do we want to know? EG, well, by the Pythagorean theorem here, 6 squared plus 8 squared equals x squared, and x is going to be 10. The area of the base, because the base is a square, it's 12 times 12 is 144. The lateral area is the perimeter of the base times the slant height. The perimeter of this base is 4 equal sides of 12 each is 48. So using the 1/2 PL along with the L that we found up here, that X, and this is our slant height, we get 240. And the volume is 1/3 the area of the base, which was 12 times 12, remember. It is the 144 we got earlier, right here, and then times the height that was given to us at 8 for the 384. Okay, this is just our rule that if the scale factor is 2 to 3 for similar solids, the ratio of their area will be 2 squared to 3 squared, 4 to 9. We just square the scale factor, and the ratio of their volumes would be 2 cubed to 3 cubed, would be 8 to 27. You always cube. Think of area square units. We're going to square the scale factors. Volumes are cubic units. We're going to cube the scale factors, and perimeter would just be the same as the scale factor. So here's a little problem. If the volume of a larger solid of 2 is 54, and this one right here, and I'm continuing with the same problem, then find the volume of the smaller. Okay, well, 8 is to 27. That's the ratio of their volumes, and that's what it's supposed to say down here. 8, 27. So 8 is to 27, as smaller is to larger, x is to 54. You just cross multiply and solve here. You're going to get 27x equals whatever 8 times 54 is. And then if you divide, x will be 8 times 54. Sorry, 8 times 54 divided by 27, which works out to be 16. Okay, last page. Okay, so we've got a cube, and I'm sorry, we have a cone first. And we know its height and its radius, and we're just trying to find its volume. Volume only depends on radius and height. It's 1/3 pi r squared h. This works out to be 98 pi over 3, or 102.6. These seem like repeat questions, so I would think I'm not sure why I've got them in here a couple times. Here we have a cube of length 5. Remember, we said earlier that a cube has 6 faces and they're all the same. So the area of one face would be, in this case, because they're of length 5, would be 5 times 5 is 25, times 6 equal faces gives us 150. And the volume would just be length times width times height. 5 times 5 times 5 is 125. Appropriate units, square centimeters, cubic centimeters. And here there are quickie formulas. They will not be, the shortcuts will not be on the test. The only formulas on the test will be for prisms and pyramids, cones, cylinders, spheres. But you're welcome to these shortcuts. Otherwise, you can use the right prism formulas, which just takes a little bit longer. Here's another problem. I did have to change the words here to make this appropriate. The two similar solids have areas of 36 square inches and 49 square inches. Suppose that means total areas. So we know that the ratio of areas will be the square factor squared. So a squared over b squared will be 36 over 49, the ratio of their areas, which gives us scale factors by taking square roots of 6 over 7. The heights are in the same ratio as the scale factor. So 6 is to 7 as the height of the smaller is to the height of the larger. Cross multiply and solve and you get 3.5. And then our last problem, we have an equilateral triangle for base on a right prism. Each base edge measures 10 and the height of the prism is 4. Okay, the perimeter of the base, here's a picture of our base. And it has 3 sides that are 10 each. 3 times 10 is 30. The lateral area is perimeter times height, so it's our 30 times the 4 that we're given here for the height. 30 times 4 is 120. Now there's 2 ways to get the area of the base. Over here, this is the entire base. And you could use the Pythagorean theorem to find the height of that triangle at root 75. And then area would be 1/2 the area of the, by the triangle formula, the area of the base would be 1/2 base times height, which is 1/2 of 10 times that root 75, which works out to be 43.301. Another choice is you could use the 1/2 AP formula. So this is just the central angle taken out of that triangle, the second central angle triangle. The measure of the central angle, 360 over the number of sides, is 120. Then you're going to, here's 60. I can use tangent. The tangent of 60 is 5 over A. 5 coming from the 10 being split up into equal parts, just like it was over here. Which gives us A is 5 over tan 60. And the area of the base then is 1/2 the apothem, 5 over tan 60 times the perimeter of 30. Either way, you get the same area of the base at 43.301. Then we take that up here for volume. It's the area of the base times the height. We already knew the height, so we just multiply and get 173.2. Hope this helps. Good luck tomorrow on your test.